Okay. So limit as x approaches negative infinity. And then you're going to focus on the leading terms. And then you're going to simplify it. How does that simplify?
That simplifies like I mean it's just limit over x goes to negative infinity and then it's just 0 usually.
No. This fraction. Let's
Oh,
simplify that fraction.
the fraction. Okay. So you cancel out the x
Good.
usually.
So you get 7 over x,
It's
right?
7 over x, yeah.
Yeah, and then that's going to be 0. Because x is getting really large, while 7 is just 7. And when you
Yeah.
have a number over a large number, it's just going to be
You.
0, pretty much. Yeah. Okay. So let's try another one that's pretty similar, like number 6. And then we'll do the other ones that involve some factoring.
Okay.
And one thing you want to be mindful about, you don't want to get lazy. You always want to write the limit notation
Yeah.
until you're ready to evaluate or substitute. So the leading terms are this. Now, how do you reduce that?
You cancel out the x squared.
And what's negative 14 over 7?
It's -2.
So the answer is just be negative 2. Correct. Okay. Now let's take a look. Okay, so what you want to do for these problems, like for number 2, you can just plug in 1, and that's fine. Sometimes substitution is okay. And actually, you should always check the substitute first, always. Because sometimes that will do the trick. And once you substitute, you don't need to write the limit notation.
Okay.
So you get -9 over 21. And
Okay.
that reduces to -3/7, I think.
Okay. Oh yeah, I see.
Okay. But now let's take a look at 5. For 5, if I substitute, I get 2 times 9, because you have to square it, minus 36 plus 18 over -3 plus 3. Now, what happens when you do that?
-3 plus 3. You get that over 0.
Yeah, you get 0 over 0.
Yeah, you get 0 over 0.
So when this happens, this means that we're going to have to use some other technique like factoring or something else. So we're going to want to factor here in this case. So the bottom is what it is, right? And again, we can't get lazy. We have to keep running limit notation.
Okay. So like you just factor them out like normal, right?
And I can pull a 2 out.
Yeah, you get it like x. Oh yeah, you do 2 times and then x plus 3 and then x plus 6.
Yeah,
Or no,
good.
x plus
Excellent. Right
x
on,
plus
man.
3 and x plus 6.
Actually, no, it'll be x plus wait one sec. Hold on. No, x plus 3,
Right,
x
no,
plus 3.
yeah. It's just x plus 3, then x plus. Oh yeah.
Yeah, because I should probably pull the 2 out first. I was trying to skip steps. Yeah, so those cancel. And then you can substitute -3. You just get 0 straight up.
Oh, okay, I see.
Yep. Okay. So we take care of 1, 2, 5, 6. Now let's take a look at 3, 4, and we'll do some other topics. So for 3, and give me 1 second, we'll be right back. Hold on.
Okay.
All right. So, um, so for 3, you're gonna do this limit
Okay.
negative 4x cubed
A over 10x squared, yeah. And then plus 92.
So how's that reduce?
Oh, no, just no, not plus 92. Sorry, not that. You cancel out an x squared.
Mhm.
So you're left with negative 4x
Mhm.
over 10.
Right. Now in this case, because x is approaching infinity, the fraction is just gonna keep getting bigger because you have x on the top, but just a plain old number on the bottom.
Yeah,
So that's gonna be infinity. Actually, be negative infinity. Or you say D and E. Does the teacher care how you say it?
uh, usually yes. Like she makes us do like from that other package. She's like, oh, D and E, but f of x goes to here.
Okay.
Yeah. So just like D and E, but f of x goes to negative infinity.
Sure, that works. Mhm.
Okay.
Yes, that works. Okay. Yeah, I see in your notes here. Okay. Okay, good. And define for 4 before we do other problem types.
Hmm.
That's approaching negative 3 from the right side. So you might want to
Yeah.
think graphically what's happened here. There's gonna be a vertical asymptote at negative 3,
Uh-huh.
and a horizontal asymptote y equals 0.
Yeah. So there's that. Okay. This looks like that. And after that, you just wait.
So
So
what's
like,
happening is as you're approaching negative 3 from the left side, it's going down forever.
okay.
So you get
Oh,
negative
yeah.
infinity or D and E.
Yeah. Oh, yeah. That's a
So you could graph it. We could also plug in a number close to negative 3, like negative 2.999.
yeah, but she usually wants to put this
The graphing.
the D and E at
No,
infinity.
of course. But I mean, but in
We don't
terms of
actually have to put the graphing.
got it. Okay. But it helps to understand what's happening.
Yeah, it does.
Yeah. So
Okay, and then for 7a, so limit negative infinity, y is going to positive infinity for 7a.
Hold on, give me a sec. Right, that's gonna be positive infinity.
Yeah.
That's gonna be 0.
Yeah. This one's 0 as well, yeah.
At 0 because it's straight up, right? What do you think about
For D, negative 1.5, uh, I guess just the y goes to negative infinity then?
negative 1.5? No, negative 1.5 is over here.
Oh.
So
Oh,
what's y approaching as I get closer to negative 1.5 from the left side?
oh, I see. It's a -1. All right.
Good. Okay, how about 2?
And then number 2. Oh, yes, I see. It's I mean, there's nothing there. It's
At 2, so it's going down forever.
yeah, so it's negative infinity or
Yeah, on both sides going towards infinity or DNE. Now here, that's approaching -1. That's just that number, which is 4. If you're approaching -3,
okay. Yeah, okay, and approaching -3. That would be -1. Should be.
Yeah, that's gonna be approaching -3. It's gonna be -1, correct? And then -1.5 from the right side, what's that gonna be?
A -1 from the right side. Oh, it's -1.5 from the right side. But
Right. So what's y approaching? If I'm getting closer to
it would be
-1.5 from the right side.
2.9 around there.
Yeah, I'll say 3. I think 3 is kind of fair, but sure. Okay. All right, cool. All right. Okay, so I have to use this graph. Okay. Okay, formal definition of continuity, very important. Okay, let me minimize this just a tad. Okay, let me write the formal definition of opposite margins here. So there's 3 things you need to consider. F of C exists,
Okay.
where C is what X equals. The limit, I mean, you can use any letter really. I don't know why I use C. I guess some textbooks do that. The limit as X approaches C of F of X.
Okay.
This. And FC equals limit. So you need to make sure you have that down cold.
Okay.
Because you don't, you're gonna miss points. Guaranteed you
Yeah.
will.
That's what
Then
happened.
what you do is explain if it's continuous or not using those conditions. So starting at -3, it's not. So what you would say is that you say no, because, and that's because the limit does not equal f of -3. So you could say, f of -3 equals -2. The limit as x approaches -3 f of x is -1. And f of -3 does not equal and there you go. So that's how you have to say it. You have to show me what f of -3 is, show me what the limit is, but A, they're not the same. That third condition failed.
Okay.
So basically go 1, 2, 3. 1, 2, 3. Like for -1.5, so let's go with a contrast. The limit as x approaches -1.5. And I'm going to do minus and plus. That's going to be
Okay.
-1 from the left side. For right side, it's 3. So then you could say, since the left-hand limit, the answer is no again.
Okay.
Does not equal the right-hand limits. The limit
Okay. I see.
does not exist.
Yeah. DNE just put no. I see.
That's because the first condition or the second condition, I guess, doesn't matter. Well, yeah, the limit does not exist, right?
Uh-huh. I see.
Um,
And then x equals 2.
for x equals 2.
I mean,
So
that
it's not defined. So you could that's no again. And that's because f of 2 does not exist. Because it's not part of my domain.
okay, I see. Hmm. Okay, and then for x equals -4.
So x equals 4, that's yes.
I mean, x equals -4, that is yeah.
And that's because f of negative 4 exists. Or we could just say f of negative 4 what it is. That's going to be 0. The limit
Okay, I see.
also equals 0. And then lastly,
Okay, I see it.
yeah. And so you just have to state those things from those conditions.
I see. Okay,
So that's continuity.
I just need to explain more next time.
Um, so it looks like this is old stuff. Does your teacher put old stuff on tests? Like
Uh,
previous units?
uh, no, no, no.
Some teachers do. I was just curious. Okay. We'll skip 9 for now. Um, let's look at the rates of change.
Okay.
Let's see here. Okay.
Hmm. Okay, and then like that one. Shouldn't we do like oh
Yeah,
no.
give me a second. I'm trying to understand your work for part B. Um,
Yeah. I don't think I finished that one.
okay. No, you didn't finish yet. So what you want to do for part B, actually, let me look at your answer for part number 10. I'm just kind of, yeah, it's with the minus. Okay. Find the LCD. Okay. Okay, so the red, is that your handwriting still?
No, that's the teacher. She came over to help me.
Okay, does that make sense? What your teacher did?
That does make sense.
Yeah, so you just got to keep going. Right, okay. So, and actually, I would suggest what she does is like, hey, let's calculate f of 3 separately, f of 4 separately, then bring it all back at the end. It makes it a little cleaner. Okay. So let's talk about how to finish off the problem for part B. So you can have 5 over 5 plus h plus
Okay.
15 plus 3h plus 1 minus 17 all over h. So you should get
Hmm.
okay. So it's just a very weird problem, but then you need to simplify it, which is going to be a little tricky. Actually, I mean, I think you probably leave it like it is. I don't know how much your teacher wants you to simplify it.
She usually just means as much as you can.
Okay, I mean, technically speaking, you're dividing by h. H by itself is h over 1. You could flip it. So it becomes this now, 5 over 5 plus h plus 3h minus 1.
Okay.
So then you get 5 over
Hmm.
I mean, I suppose you could do that. I don't know. But yeah, I'll just leave that alone for now.
Yeah, I don't think you can simplify that further.
Yeah, because I think, yeah, okay. Okay. Let's do the tables problem down below. That's a good one to do. Then after I finish, I want to show you a practice test that you can work on. Because I'm actually
Yeah.
teaching my pre-calculus class right now, this material. Okay, average rate of change in the bounds for each given. Really? Look how the average change in the bounds. Oh, that's not hard. Okay. So what you do is you could add another row. Or
Okay.
actually let's treat it like this. I'll make a table like this here. So obviously this interval is from 0 to 1, then 2, then 3, then 3, and then 3.
Okay, I
Yeah, because you
understand.
have 1 interval, 2 interval, 3 interval, 4 interval, 5 interval.
Okay, I
Then
see.
the change in balance, that's when I need a calculator to do this one. I don't feel like doing this in my head.
Hmm.
You had 769,
769,
negative 172.
172.
And let me partition this so it's easy to read. Hmm.
Hmm.
Okay, so that's all you're doing for part A. It's just you're kind of setting it up for part B.
Yeah.
The part B says assume the count balance continues in a similar pattern. How much money would you expect to be in the count after 10 years? Well, I don't know. This is so it's going up and down. Um, I'm not sure how you would answer that question.
Uh.
That's weird.
Huh.
I mean, I guess you could try finding.
Wait. Wouldn't the interval be like 0, 1, 3, 6, 9, 12 or?
No, the interval, you have to take the difference.
Oh.
And because time is X and balance is Y, you're doing change of Y or change in X, essentially. That's what you're
Okay.
calculating.
I think I understand.
So then when you actually I'm not done yet. So then what you do, if I extend this,
Okay.
so when you calculate the average rate of change, that'll be 769 it'll be negative 86. 249 divided by 3, that's 83. It's negative 122.
Okay.
That'd be 29. But I just don't understand what he wants to do for part B. Like that doesn't make any sense. I mean, you could. Yeah, the problem just seems weird to me. I suppose you could do this. I mean, if you did say find the average rate change from 0 to 12, then you would do this then. You do 1074 minus 507. And since
Okay.
you do, and you can do it in terms of years, that'd be 0 and 1 year.
This is
75, 67 per year. Then you could make an equation, y equals 567x plus 507. And then plug in 10 for x and solve for y. I mean, that seems to be kind of what I think your teacher wants you to do. That would make more sense. Like the calculate average rate of change and then use that to write an equation of a line and then calculate. But the thing is that this is not really linear because it's going up and down. So it just seems really weird to me.
yeah.
I mean, I'm not quite, I'm a little unclear of what your teacher wants you to do here. I don't know.
Yeah.
Anyhow,
Yeah, that's about all of them.
okay. Well, let me show you one of my practice tests here. Maybe one of my homeworks might help too. Let's see. Yeah, give me a sec here. Yeah, cool. Yeah, so should keep this. You're good. Okay, this is good. I mean, some of these may not. Okay. So definitely let me send this your way. That'll be good practice. So we can kind of get a head start to it. Give me a sec here. Let's see if I have anything on rates of change. Here. 25 maybe. Yeah, okay. Let's keep that one. Okay. We'll send that your way also.
Okay.
That's rates of change practice. Cool.
Okay.
That's good. I'm glad we took care of that. So I do have to peel off in about 3 or 4 minutes, but I think what would make sense is to do some practice over the next day or two, and maybe we check in one more time on Thursday before he tests. Um, I could check with your mom
Um,
about.
I can't.
Oh, you can't meet Thursday. You're busy Thursdays.
Yeah. This Thursday at least.
Okay. Um. Well, how are you feeling about the material right now?
Right now I understand the limits good.
Okay.
Um, I mean,
Well, let's do this. Let's have you do an
I
average rate
understand
change.
the limits good. The only thing I'm kind of iffy about are like those really long average rate of change problems.
Okay. Let's do that then. Okay. How about this? So why don't you go and do number one, part A, and number two, part B. So number one, part A, and number one, part B.
Okay.
So here's your equation. Here's your interval. And also part B, here's that interval.
Okay. Okay. So number 1A, that's I got like the square root of 9 minus 1, and then over
Mhm.
2 over 2.
Good. Okay.
So
Okay.
that's just like
Yeah.
2 over 2, which is 1.
Okay. You're doing that's good. You got it. Okay. That's good. All right. How about you try part B?
Part B, uh, square root of I got the square root of 41 minus the square root of 49. And then all over 2 as well. I got I got negative 0.29 after I divided by 2.
Sorry, repeat one more time.
I got like negative 0.29.
Okay, let me double check. So you have 7 minus root 41. Divided by 2. I'm sorry, you got negative. So
Yeah.
hold on. When you plug in 12, did you get root 49
Yeah.
minus root 41
Oh, I put them wrong. Sorry.
over 2? Okay.
I put them wrong.
Yeah, that's what you should be getting. Okay, I do need to get going. Well, due to limits problems also, maybe you can send me a picture of your work and I can give you some feedback by text or email.
Okay.
Because I still would like to kind of just kind of check in with you quickly before you test on Friday. And then I can't do Sunday at 5. Let me get back to you on my schedule for the weekend as well.
Okay. So you
I'll,
cannot do Sunday at 5, right?
I can't no 5 I won't be able to do, but I'll get back to you on that.
Okay.
Okay, cool. Well, I'm gonna still shoot your mom a text. I'll try to do it tonight if I get a chance. So
Okay.
okay, all right, cool. Well, we'll talk soon.
Talk soon. See